Welcome back. So let's try a tough conversion problem. So let's take a solution that is, say, 5.1% by volume of butanol. So butanol is C4H9OH, and maybe it's going to be aqueous. So butanol, I don't know if it's that soluble actually in water, but let's give it a go. We want to go ahead and we want to convert this to maybe a molal concentration. So the question is, how do we do this? And so we probably want to start with what exactly do we mean by 5.1%? And that tells us that there's 5.1 milliliters over 100 milliliters of the solution. And so it's 5.1 milliliters of butanol. Okay, and we want to convert to molality, so we need to figure out how many moles of butanol that is per kilogram of the solvent. So it's aqueous, that means it is water. So that is our plan. So really we just need to convert to milliliters of butanol into moles of butanol, and we need to find some way to convert milliliters of solution into kilograms of water. So we can go ahead and recognize density is mass over volume. So if we want to find mass, then that is density times volume. So we're going to go ahead and we're going to find the mass of butanol. So 5.1 milliliters times by the density, so that is 0.81 grams per milliliter. I should have given that in the problem, shouldn't I? So the density of butanol is 0.1 or 0.81 grams per milliliter. And that is going to give us the mass of butanol, which I get to be 4.131. Again, to two significant figures, I probably shouldn't write out past there, but I'll keep a couple of guard digits. So how does that help us? Well, we're trying to go into moles, so we know how to convert grams into moles, hopefully. So 4.131 grams. And if we add up the mass of 4 carbons and 9 plus 1, 10 hydrogens and 1 oxygen, then we get the molar mass, which I get to be 74.12 grams per mole, so that is grams of C4H9OH, 1 mole of C4H9OH. Right, so that gives us moles, and I'm getting 0.0, so those leading zeros don't count, 5.573, and I probably really shouldn't go past the second significant figure, but I'll keep those as extra digits there as guard digits. So that would be moles of my butanol. So I've got the top now, so all I got to do is figure out how many kilograms of water I'm dealing with here. So now I'm going to work with the bottom side of this. So I got to turn 100 milliliters into kilograms. You might just say, well, hold on a minute. I think 100 milliliters of water weighs 100 grams, and so that's 1/10 of a kilogram, so I am there. But actually, your solution isn't pure water. Remember, your solution is water plus butanol. And so if I look at the water, if I had 100 milliliters of solution and 5.1 of them are butanol, then it turns out that 94.9 milliliters are pure water. And I need to convert that to mass. Now, I need the density of water. So again, I didn't give that in the problem, but maybe the density of water is something like 0.996 grams per mil at these temperatures. So I know density is mass over volume. So mass is density times volume. All right, so our volume is 94.9. Our density is 0.996. So because that is so close to 1, it's really not going to change things around very much. And if I multiply this out, then I get 94.52 grams of water. And I want it in kilograms, so I divide by 1,000. So that is 0.09452 kilograms of water. And at this point here, I have the bottom, and we also have the number of moles, which is the top. So I just need to divide one by the other, and I get the answer. So I just shifted that up slightly. So my molal concentration now is the number of moles, so 0.05573 divided by the number of kilograms of my solvent, so 0.09452. And I can see I've got two significant figures here. And so at this point here, I can round, so 0.589 becomes 0.59 moles per kilogram, or just M for short. So it's 0.59 molal. And you should be able to do that. There's lots of end of chapter problems I would highly recommend you try. I'll give you a couple on the quiz as well. But make sure you can begin to convert any one of those 5 concentration units with any one of the other 5. And I would just highly recommend you start by writing out, what does it mean? What am I looking for? And most of the time you're just kind of trading the top and trading the bottom, and just trying to make use of things like, I know the solution is solute plus solvent, so if I know the solute part of it, the rest is solvent, and Bob's your uncle. So have fun. It's a little bit of trial and error at first, and then you start to kind of figure out these plans, but eventually you've just done all of them 1 or 2 times, and you just kind of recommend or recognize how to get this stuff done. So good luck, happy hunting.